Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing you another really fascinating guest today, involved in creating a better tomorrow on some really unique fronts. Today, we have the honor of being joined by Dr. Julia Allen, who is Chief Scientist for Autonomy and Artificial Intelligence at Saab, where her team's primary focus is on developing artificial intelligence technologies to ultimately support the organization's customers across all United States Department of Defense branches, helping government research and development leaders take on some of their hardest challenges. Saab currently serves the global market with world-leading products, services, and solutions in the defense area and all domains related to civil security. Previous to this current role, Dr. Allen was the Director of Artificial Intelligence and Tactical Space Research at BAE Systems FAST Labs, was the Principal Investigator of their DARPA MindfuL Competency-Aware Machine Learning and Office of Naval Research Advanced Long-Range Targeting Programs. And prior to joining BAE, Dr. Allen was a member of the senior professional staff at the Johns Hopkins University Applied Physics Laboratory, as well as a military intelligence officer in the Army National Guard. Dr. Allen is a graduate of Dickinson College, did her undergraduate degree there in mathematics, moved on to do a master's in applied and computational mathematics, and ultimately a Ph.D. At the University of Maryland. A lot of really interesting themes to get into today. We're really excited to have her. But Dr. Julia Allen, welcome to our show.
Thank you so much, Ira. It's a pleasure to be here.
It's really great having you, Julia. I've looked forward to doing this episode for a while now. So glad that we have you. Would love to start off because you've been on quite an amazing journey, and it's going to be exciting getting into some of these themes. Would love to start off just by handing you the floor for a little bit to talk about yourself, a little bit of your background. Why mathematics, why applied and computational mathematics, and if you can take us into some of your early days. You've served our country in the Army National Guard. You also applied those mathematics skills. I did not mention the Aberdeen Test Center. Take us to the early days. How did this all get started? This amazing journey you've been on.
Yeah, great. I was raised in a military family. I actually started school in Hawaii in the public school system there, which is a very different culture than where I moved to in Pennsylvania in terms of free-flowing curriculum and really a culture that just inspires creativity by its nature and what you're surrounded with in terms of natural beauty there in that state. But then moved to Pennsylvania and had some great teachers, especially in math and science. Very rigid classroom environment in comparison, and ultimately won the fourth grade science fair. And that was probably the last time I talked to the media in a similar sense as this. When I was interviewed at 9 years old, and quoted in the paper as saying, "I like science because everything is science. Inventions are science, and everything is an invention." So I think that is kind of illuminating of how I thought about the world even then. And how I got into mathematics was really out of curiosity and having good exposure early on to different techniques at a very young age through the Carlisle area school system in Pennsylvania. But both my parents worked very hard. It's kind of hard to tell who worked harder, even though my dad had a very traditional 30-year career in the military as an Army infantry officer, and my mom was primarily a caretaker for the family and for him writ large. But it was difficult to see who worked harder, even from that perspective, which I think played into how I became the way I am, just always on multiple sports teams, piano lessons, always filling the days, everything from basketball, soccer, lacrosse, bowling, tennis. I played a lot of different sports. And that's kind of how, from morning to night, every day was filled. And I think that comes through later in my career, where I was always doing more than probably others thought was normal, with full-time employment, part-time in school, part-time in the military, and being able to balance those three really different non-overlapping careers for more than 8 years, which is a long time to be doing that much, as I've come to realize later on, where I'm just focusing on one job or one career path at this time. But yeah, math came easy to me. I think, having a very good memory was one way that I got a leg up, in a sense. I think exercise by classical piano and memorizing techniques and kind of just conditioning on that sort of way that my mind works lend itself really easily to math and the different processes and formulas that you use, especially at a young age, to solve different problems. But I really wanted to follow in my father's footsteps as far as a career in the Army. For the the majority of my young life, I think, maybe age 8 or 9 to age 16, I wanted to go to West Point. I wanted to become a lawyer in the Army and kind of follow his footsteps there. But then my junior year of high school, I decided I wanted to take a year off, move to San Diego, bartend, become a sports agent. And ultimately, my senior year of high school, I decided to go down the road to Dickinson College, which was closer to my parents' house than high school, major in math, and join the Army National Guard, or join the Army ROTC at the time. So it's kind of an interesting, little insight into my adolescence there. But it all worked out. I applied for the SMART scholarship, which is the Science, Math, and Research for Transformation scholarship that the government offers, which is actually a fellowship where you serve, they pay for your school and you serve in government service thereafter, which ended up being really great, because then it would allow me to start a civilian career while also starting my military career, but on the National Guard side rather than active duty, which I had originally intended. So that was a positive experience. The fellowship was with Aberdeen Test Center that you pointed out, which had a really important mission, which is still near and dear to my heart today, and test and evaluation of military systems, equipment, weapons, vehicles, etc., making sure that they're safe and ready for deployment and use in the military. I also was able to work on the Joint Light Tactical Vehicle program, which was the replacement for the Humvee, which is still in the works today of getting rolled out, even, I guess, 10 years later, which is interesting. And that was a full-on competitive test among vendors to determine which vehicles were at the best readiness for the military. I also got involved in Lean Six Sigma and defense acquisition universities, and that kind of laid the foundation for understanding how to look at processes a little bit differently, and how the government works when it comes to procurements, which is a beast, but very much helps provide context for when I'm working on proposals now, or when I'm working with government leaders and program managers that have to work within that very complicated and cumbersome process of budgeting and allocations and awards and fairness and competition and that sort of thing.
Yeah.
And that's kind of what closed out that first chapter, along with military training as a military intelligence officer in Arizona for about 4 months, and working on a master's degree in applied and computational math you asked why that particular discipline, and the reality, I mean, that all I can think of to answer is that I was really excited about optimization methods. I really loved the idea of breaking the world down into problems where you have an objective function, you have some constraints you have to work within, and you find the solution that is optimal, provably optimal for whatever problem you're looking at. And that was really exciting to me, also helping look at the world a lot differently. And that background at the time, I didn't, had no idea I was going to get into machine learning later, but those sorts of problems are really the foundation for reinforcement learning, which came in handy, and also on how even supervised learning is conducted, where you're solving for a loss function to train an algorithm to learn how to do things optimally in the traditional machine learning sense.
And that leads, beautifully into sort of the domain of your Ph.D. at the University of Maryland, which is, this is in the Department of Mechanical Engineering. Your focus is on explainable artificial intelligence. Your dissertation title, towards trust and transparency in deep learning systems through behavior introspection and online competency prediction. And I have to say, this, I was going to get all the way into it, but some of the things you talk about in your dissertation, per sort of the analogy between air-to-air combat and ballistic missile defense, and things like football, and how one has to make certain decisions when a pass is made, how to catch it, where to go, how to intercept. These interesting analogies, feeding back to sort of this understandable AI, this competency. And as we chatted before the show, that Jianqing Zhao, I had her on shows twice. One time, when she was at DARPA DSO, and then now at Raytheon. I know sort of some of the work she was doing obviously laid the groundwork for what you did following in terms of the mindful AI. Spend a little time on this, because I find it personally fascinating, but also, I'm a child of the late 60s, early 70s. And, there was this really cool movie when I was growing up called War Games, where, Matthew Broderick had to teach the AI competency and had to play games like tic-tac-toe and other stuff to make sure it didn't start a nuclear war. Take us into some of this work, because it is completely fascinating. Would love to hear sort of how you got involved in some of what you were working with at the time.
Yeah, no, explainability has a huge impact on how machine learning is actually adopted and used. If we don't have that, then really we're limited to using machine learning for very low stakes applications, where it doesn't matter if you're right or wrong. We don't care how it got to the result. We just want the best result that it can give us, and use it to the extent we want to, or throw it away. And I think the explainability, along with other things like repeatability and being able to have that tie back to the inputs all the way through to the outputs of how a machine arrived at its decision, is what's going to allow us to take it to the next level and use it in those higher stakes applications. And Dr. Zhao, as you pointed out, had a beautiful vision at DARPA, which really inspired me at the time, and other colleagues, including Dr. Matt Henry, to respond to that proposal to form a team and address her vision, which was really centered around determining what conditions that were present in the data would lead to different machine learning strategies or behaviors that would then be attached to different performance levels. And so making the connection between the conditions in the data and the performance and everything that happens in that neural network in between was kind of the challenge, and obviously related to explainable AI and DARPA's vision for that writ large. So I really focused in my dissertation work on extending what we had done on mindfuL at BAE Systems FAST Labs in collaboration with MIT, CSAIL, and looked at it for a reinforcement learning application, which I alluded to earlier was related to my background in optimization, for this pursuit game where you have one pursuit agent trying to capture an evading or an otherwise uncooperative agent. similar to those analogies of air-to-air combat and football, and being able to anticipate where the other one's going, come up with a strategy implicitly to capture the target in that sense. And so what I did is look at the activation patterns, which are all of the outputs from the nodes in the neural network over time, to analyze what strategies were being used by the machine learning agent in different cases. So those different patterns could be reduced in dimension to something that you could group and cluster and determine the similarity between. And that's where we discovered that those strategies were related to performance. And that's a really key insight, because if you know what strategy is being used, you can then understand how successful it will be in that case and why, in the sense that you could group it into a strategy, something like a L-shaped maneuver or a direct line of interception of that target in my case, and being able to explain that. Some of them didn't have any interpretable meaning to humans, where you could just group them together and say, this strategy is similar to these other strategies. In those cases, they ran out of time before they reached the target, or otherwise had some even distribution over the outcomes, and they weren't very insightful. But being able to understand when you're in a situation where you can explain the machine's behavior was definitely a step toward the explainable AI mission. And I will say, with the work we did on mindfuL, we also had a really exciting discovery in terms of being able to relate the input data to one another, and being able to determine likewise what performance characteristics were associated with those inputs. And it makes sense, right? If you've trained an algorithm to do a task a certain number of times on data that look like this, and the current sample you have doesn't look like anything you've seen before, you wouldn't expect to get a reliable performance in that sense. Whereas if it aligned very closely to something that the agent has been trained on, you would expect it to perform similarly. That was the hypothesis, and that determined to be able to be useful insights to share with the user that, hey, I've seen this task some number of times and performed in this characteristic band. Mm-hmm. So that was very interesting, but it was an exciting project to work on. It really inspired me to dive deeper into it on my own time as part of my dissertation work. And I'm glad that I went that route, because as things have evolved, and now we have transformers that have attention mechanisms, and there's all this discussion about if these attention models can be used for explainability. It's all happening now. And I think those are still open research questions, and credit to Google for publishing the Attention is All You Need paper, which has really brought about a lot of this GPT breakthroughs.
Right. Awesome. No, again, it was really awesome work. I enjoyed being a life sciences guy to the extent I could dive into it, but just it was really as you're saying, you're not just on the cutting edge, but the cutting edge of sort of this machine learning introspection and competency and understanding. It's fascinating, and then it sort of sets the stage for sort of why you're doing everything you're doing now. But I appreciate you,
and I will credit the team. The team at BAE and MIT were a joy to work with and get that kicked off and started, and even the other performers on the Competency-Aware machine learning program. We learned a lot from each other, and Dr. Zhao and her CETA team did a great job of facilitating that program's progress. It was really fun.
Awesome. Yeah, it's awesome. So, Julie, take us a little into the Saab organization as we approach 2024, because unbeknownst to me until a few months ago, I did not realize you didn't make cars anymore, but that's cool. You make all sorts of other neat things like radar systems and airport security systems and cool things we'll be talking about in terms of maritime. But there was an awesome article by the Saab organization about you and your team, all about the autonomy and AI, and that your primary goal across the organization now is to make all of our stuff, products, services, smarter. Before we get into some of what you're up to, just talk about Saab and a little bit of its evolution for those that may be unaware of what it's become versus what it
Yeah,
was in the past.
as you point out, we don't make cars anymore. So the running narrative in the company is that when it comes to the global footprint of Saab, it's everything but cars.
Yeah.
In Sweden, we really were the military industrial base supplier for the nation of Sweden. So when it comes to everything from submarines to fighter jets, Saab is the major supplier there, and that footprint has extended globally in different areas and different domains. The U.S. really, the bread and butter has been radar systems and air traffic management for a number of years since the acquisition of Census Corporation, which is headquartered in Syracuse, which is why Saab in the U.S. is headquartered in Syracuse today. But and recently, even since I've joined Saab about 2 years ago, we've been expanding in three other business areas and doing all of them in parallel. So we've got three new divisions, one of which I was the co-founder of, and we'll talk about later, I suspect. But the two other divisions are the training and simulation and land systems group that's down in Orlando. So there we've got the software that we're transitioning from Sweden and doing technology transfer to the US for force on force training exercises with ground combat troops. So I think a lot of kitted up Marines that are involved in a force on force exercise, thousands of Marines that are doing training at different live test ranges where their positions and what they're doing all floats up to this environment that Saab manages to understand where everybody is, what the current battle situation is, and how to track it, which is, of course, near and dear to my heart with my background in the Army National Guard. And I see a lot of promise there with the amount of data we're collecting and how to use AI and even autonomy in the sense of augmented reality to generate a stronger training experience or be able to provide more insights into what's happened during those training events to the observers and controllers of the exercise and overall exercise directors in the Marine Corps. And we've also got our aerospace division that's in West Lafayette, Indiana, which is right next to Purdue's campus. And I've been heavily involved in working with Purdue on both autonomy and AI programs since I started at Saab because of that co-location. Saab's new facility is adjacent to campus in the Purdue University Discovery Park, which has a lot of advantages when it comes to working with Purdue just by the nature of convenience. But that's where we manufacture the T-7A trainer aircraft fuselage in collaboration with Boeing for the U.S. Air Force. And again, there's a lot of opportunity for how to inject smarter manufacturing practices in terms of processes that are used and ultimately how to understand the training validity, the training experiences with that aircraft as well in the future. And the last division, which I think I can provide some insights into, is the Autonomous and Underwater Systems Division, of which I was a co-founder with two others about 2 years ago. Did not exist.
Nice. And as you again, another perfect segue, because one of the things that we also discussed previously to the show was sort of your clearly you have marching orders. Let's say we got to make these devices or systems smarter. At the same time, you have, as you mentioned, you're setting things up from scratch. You mentioned this entrepreneurial role within the organization, which is always exciting because it's a giant company, but yet you have the ability to experiment, to play a bit, and at the same time talk about this because it's you wear two hats in this sense, that right? I mean, you have major corporate things, but at the same time have the ability to almost in a little sort of a tiny DARPA way to play for a while on some of these things. Say a couple words about the entrepreneurship angle of this, if you would.
Yeah, you wear a lot of hats.
Yeah.
You wear a lot of hats. It's like being a part of a startup, but with the resources of a large organization to back you up instead of VC and other investors in that sense. But yeah, Jeff Smith, who's the VP GM of our Autonomous and Systems division, joined Saab from BAE FAST Labs, where we had worked together briefly after his company was acquired by BAE. Came to Saab, and I joined him here to start a new division. We didn't have, we had a wide scope in the sense that we could start with undersea, we could start with surface, we could start with the remotely operated vehicles, we could leverage my experience in autonomy and AI and how to get started. So that's a pretty wide aperture of business scope that had uncharted territory in the US for Saab. And so we worked to pursue the opportunities that were available at the time, and captured a new program with DARPA, a new program with ONR on the autonomy and AI side. This is when it was just myself here who had that experience, leveraging our relationship with Purdue to bid those cooperatively, and organically built out the autonomy and AI team from scratch. So I was able to hire my own team. That team is very much in full swing today, 2 years later, performing on both of those programs, with the customers that are really excited about what we're doing for them in those spaces. And then Jeff, with his background in undersea, and Tony LaRusso, who also was the third co-founder of the division, we put together a proposal for the Navy's Expendable Mobile Anti-Submarine Warfare Training Target Program, which is a 10-year program, upwards of $200 million over its lifetime, in very small training targets for the U.S. Navy that emulate submarines. Mm-hmm. So we were able to capture those 3 programs within our first year or so here, which total about $215 million, which is how we grew the team from 3 to what it is today, maybe 25, something like that, organically within that time, which, it really is an entrepreneur story when you look at it in retrospect. At the time, like you said, you're given your marching orders, you say, try to win some work. It may work, it may not, the timing has to be right with your skills, and being able to source the right skills to win those very competitive programs like the DARPA program I mentioned. Mm-hmm. But yeah, no, it was a lot of fun, and now I'm joining the Saab strategy office and really getting ready to do it again, which is, I guess, my 3rd time, because at BAE Systems we also started, Dr. Matt Henry, who I mentioned, started a new group there. So I had kind of seen, one way to do it before coming here and doing it from a different perspective.
Mm-hmm. Mm-hmm. And while, you just mentioned sort of the, one of the naval or the submarine applications, I thought that'd be just interesting to talk about some of the dual use stuff that you come into contact with, because you're not just defense. And in this, there was this article in what's Inside Unmanned Systems in January 2022. I subscribed to that, but there was an article on sea sustainability, and here it's talking about the Saab Sabertooth system, which I know this is sort of one of the things that you work on, and this autonomous underwater vehicle clearly has security, has defense applications. But in this particular article, it talked all about the way you're approaching this tool for other things, in the case of environmental sustainability, and looking at things like profiling zooplankton and fish and really cool laser stuff. And I'll let you talk about it, but again, the dual use applications of some of what we chatted about on the show is always fascinating, because clearly what you do on the defense side is broad application for us here civilians. But say a few words about this program, if you would.
Yeah, the dual use space is really an open ocean of opportunity, and I think really underexplored when it comes to the defense industry. just because of all of the regulations we have to work within, and we try to apply those to everything, even when, in the dual use sense, they may be not necessary, and it's a completely different way of working and way of thinking, but there's so much promise into using what we develop for, especially in autonomy and AI, that have cross pollination across industries that, we don't know what we don't know, in a sense, but in this case, the ocean health monitoring, the infrastructure protection, whether that's oil and gas lines or communications lines or offshore wind resources that could be benefited considerably by unmanned systems, in the sense that you have reduced crude footprints, and that leads to a whole bunch of emissions advantages and cost advantages, which are obviously very important, especially in the elastic markets like oil and gas. And that's all prime. I think Elliot Donald and I wrote that article because we do see a lot of promise with the Sabertooth platform. It's extremely versatile when it comes to what you can put on it. But any underwater system that's unattended can perform these missions with some additional smarts and risk appetite from the companies that are doing this work with people. I didn't finish the entrepreneur story quite succinctly, but in addition to the organic growth I described in autonomy and AI, we recently completed an acquisition of CrowdAI, which is a very small computer vision company. But when it comes to dual use, they've been doing it for years with the wildfire detections that they're supplying to the California Air National Guard, and how to use computer vision on drones to detect the areas that have been affected by wildfires, so that you could queue resources to attend to those. Also in the search and rescue space, again, things that are traditionally thought of as used for targeting, in this case, a very, public safety mission of discovering where, downed people or ships or et cetera are, and how to queue resources to them quickly. And also in the air traffic management space, Saab also supplies some products for airport security. And again, video processing, understanding threats within airports, understanding even just the timing of aircrafts, departures and arrivals is something that is easily, I see as low-hanging fruit for applying AI to those applications that obviously can help save a lot of money, but also for the public good.
I especially like those systems to be smarter, as smart as they can be.
Yeah, me too.
Especially for those takeoffs. As you just mentioned the CrowdAI deal with Saab, and it got me thinking, because I know that Saab also has sort of this. You mentioned it acts in terms of your entrepreneurship work as sort of your sort of homegrown VC, but you also do have corporate sort of venture capital initiatives, and I assume that you work with that group as well when you evaluate some of these smaller players. But say a few words about that, because clearly in an area like AI or machine learning, which is evolving in front of our eyes, what's it like to be sort of, obviously there's another hat you have to put on, in the sense, okay, you have to be the venture capitalist to the startup that's coming in to pitch Saab about this stuff. What's that like? Because I'm more familiar with sort of like venture capital in the pharma space, and drug development's sort of been the same thing for 100 years. There's sort of a process there. But in your case, a little different, because these technology, you got to keep up with this stuff on a day-to-day basis. What's that like when dealing with some of the smaller startup innovators that you no doubt see on a daily basis in your role?
Yeah, that's a great question. And I'm definitely with the philosophy that when you're submitting to new opportunities, it's really nice to have that large company experience coupled with university that's on the cutting edge of research, coupled with niche expertise that's in a very small company, for example. But I think that niche and really being able to fulfill a need that isn't in competition with our roadmaps and where we want to go, and understanding how it's complementary versus redundant, and being able to find those companies that provide that niche expertise is really what you look for when you're putting together a team to do work. And I will say too, beyond the small business and the niche expertise you can find there, really, finding the right professors in universities that have that niche experience that spans 30 years of research in a particular topic that you want to include in your offering government is something that you look for. And I mentioned Purdue University earlier. The Institute for Control Optimization and Networks is a cross-departmental organization at Purdue that really allows me to go to a few people that lead that organization, and they identify the researchers across departments. We're talking, a sea of hundreds of researchers at a university as big as Purdue to understand who I would be looking for or who might want to contribute to this in a specific way. Mm-hmm. And, the other way of interacting with small businesses is through sponsorship in terms of letters of support that they need for small business innovation research or SIBR opportunities. Mm-hmm. And I think, I've written maybe 20 letters of support since getting to Saab and really helping them identify what potential transition partners they can have throughout that SIBR process. So, phase 1s and 2s eventually turn into phase 3s, and that's where the interaction becomes heavy with a large prime that can scale whatever innovation that they determine. And I haven't seen that through to fruition myself, but not for lack of trying and in terms of sponsoring and even reviewing the materials they're submitting and providing feedback from a technical perspective or from a scalability perspective of how they could prepare themselves best to interface to our products.
Excellent. It's fascinating listening to you talk about these tools. Obviously, a lot of them are over my head, but I do, and have had guests on the show sort of that I've been involved in translating some of them for, you brought up training and simulation and sort of augmented reality. And we did have the opportunity to profile the eye neural system at the Air Force Research Labs and sort of, how we could potentially train a pilot in 5 months instead of 6 months or whatever, using these interesting systems. Victoria Coleman, who used to lead DARPA, talked to us about hypersonics and AI. What gets you excited is sort of, obviously you're on the bleeding edge of these technologies already, but what else is coming that you're saying, hey, I got to get Saab involved in this as part of, our smarter plans. I don't know if there's quantum out there, but every quantum's a sexy word nowadays, but what are the other things that we should keep an eye out for? The things that, you're saying, hey, 5 years from now, I got to get Saab actively involved in this area or this new tool. What else is coming that's kind of exciting for you?
Yeah, that's a great question. I think, for what we're involved in already, the DARPA program I mentioned, which is ReflexAI, which stands for Explainable Reflexive Control, which is part of the DARPA Learning Introspective Control program, is really a first step. First of all, it's being able to adapt in real time to extreme disturbances in your dynamics, something that the vehicle or system has not been designed to operate under, but that the machine learning based system can infer in real time what the new dynamics are and be able to apply a new control policy in real time to address those changes. But really, I see that as a step towards self-healing autonomy in the sense that you have this system, whether it's a surface vessel or an underwater robot or an aircraft that undergoes these changes in its dynamics and is able to continue operations, the best it can. And I see that, self-healing autonomy as as a step closer to transformers and being able to have these systems that change and change and change, and the controller doesn't care. It learns how to control it in a reasonable time frame to continue safe and effective operations. Mm-hmm. Which is really interesting. You see transformers that are designed to go from one state to another state, but transformers that can adapt to their environments in real time and keep performing whatever task or maybe a new task that it's doing is something that sounds exciting to me.
Mm-hmm. Mm-hmm.
The other kind of completely different pathway is related. It addresses this issue of the replicator initiative that Deputy Secretary of Defense Kathleen Hicks recently introduced, which is how do we proliferate the production of unmanned systems? And that, naturally makes you think of additive manufacturing or somehow automated manufacturing practices that can go from a design to massive numbers of systems very quickly. So I think in the additive manufacturing space, there's a lot of promise as well. And then once you have those systems, being able to make good use of them, which will require greater autonomy when it comes to command and control and the user experience that allows one person to control hundreds of systems effectively so that they're useful. And there's been a lot of research done on that bit in the lab, but I think pairing it up across domains and really exercising it and getting to that user experience bit, which, isn't straightforward when it comes to being able to accomplish a diverse set of missions, is something that will need to be matured in order to make those useful.
Say a couple more words about, while we have you, about sort of the human factors component here, because in this whole area of autonomy and collaboration, there's the trust, right? The trust side of this, that there's a really fancy system here, and me is whatever the on the line. I forget the terminology I've learned over the last couple of years, but sort of being on the line or in the line with this really cool robot or whatever it may be. Say a few words about human factors and trust with regard to these systems.
Yeah, of course, plays a little bit on my explainability background, but more so, I haven't spent a lot of time on this on the performer side or in the research and development side, but my time in the Army National Guard then, really comes into play, having been on the other side of using systems that are deployed and seeing the number of people it takes at a division level to process the amount of data that's coming into an intelligence center, for example, and the millions of data points that are just, shown and or words that are available to process manually is where I've have the most perspective, and that's why I'm really grateful to have those experiences in the military that kind of allow me to think about these things from a different perspective. But yeah, when it comes to trust, of course, I have a soft spot for explainability and really assurances in whatever systems you're using, whether they're machine learning based or not, so that they can be used reliably in these higher stakes applications that I alluded to before. And what you see there right now is that we're willing to, and rightly so, I think at this point, we're willing to sacrifice performance to get to something that's repeatable, that's explainable. And what it happens is you're relaxed almost to a purely rule-based system that has, it could be a very complex number of rules that process a lot of data, but it's all traceable back to this piece of data led to this hypothesis, led to this conclusion, and that's what we're sharing with you there. So I think advancing those automated explainability mechanisms, maybe boosting the rule-based systems with a blend of machine learning and rule-based systems would help get an incremental step forward. But I think it's still an open research question about how to do that without sacrificing so much performance.
Really awesome. Julie, what's coming up as we get close to 2024? Anything on the conference circuit? Obviously, you probably work on a lot of top secret stuff, but any public facing things that are coming up that you could tell us about? Talks, conferences where we can listen to you, run into you possibly, and meet you. Anything else that I missed that you want to mention, please?
So I recently accepted an appointment as an adjunct professor with Purdue University. I think
nice
opportunities to be more involved in that community and their engagement is something that I would expect in 2024. And really that's, a great way of showing how strong the Saab and Purdue relationship is, in terms of me even being allowed to develop that relationship from Saab's perspective, and being able to mentor students that I've worked with over the last 2 years on these programs and different IRAD projects that we've funded from Saab, and see them through to graduation and potential recruits, and that sort of avenue is something that I'm looking forward to in 2024. And then I mentioned that I'm part of the Saab strategy team. We are in a stealth mode of sorts to create a new innovation organization within Saab, analogous to a skunk works of sorts, and really looking at how to address new markets with new technology that isn't, particularly in Saab's pocket, but to really look at high risk, high reward markets and how we can contribute either from a dual use sense, like you mentioned, there's a lot of opportunity there, or for customers that are within the DoD. Mm-hmm. So stay tuned for that. I think will be a lot coming in 2024 there as well.
Excellent. I hope we have a chance to do a follow-up episode. And especially, when you mentioned the skunk works, I really enjoy that we see more and more organizations thinking along these lines about, ultimately letting their scientists do science and not worry as much about the product per se, but really advancing sort of this fundamental stuff that gives us the future, these future situations, whether it's for our security or in the civilian sector. So really, really exciting work, Julie. I'm just I'm going to look forward to continue to follow everything you're up to. Again, for everybody who's going to be listening to this particular episode of our show across the various podcast networks or watching on our YouTube channel. Again, you've been spending time with Dr. Julia Allen, Chief Scientist, Autonomy, Artificial Intelligence at Saab, doing really amazing things to make their company's products and solutions smarter for all of us. Julia, I want to again thank you for taking the time out of your schedule to come talk to us and educate us for a little while on these amazing topics. Obviously, thank you for what you do, not just there at the company, but what you've done in terms of your personal service to the country. And as we like to say on our show, thanks for helping create a better tomorrow via the development of these tools and technologies. Really a great story, and I wish you the best with all the different programs you're going to be leading.
Thank you so much, Ira. It was a real pleasure to talk with you, and looking forward to more discussions.
Great having you.